write both the converse and the contrapositive for each statement below. In each case, determine whether the given statement is true or false. State whether the converse is true or false, and state whether the contrapositive is true or false. So if you have the initial statement, which is P implies Q, so P implies Q, which could be think, well, if P then Q, so if P is true then Q must be true. That's what P implies Q means. That's the statement. The converse is Q implies P, as in if Q then P. If Q is true, then P must be true. The contrapositive is the negation of Q implies the negation of P. So that would be not Q implies not P. Okay, so this is the statement initially. This is the converse, and this is the contrapositive. Okay, so we'll start with A, and it says if 5 is less than root 26, then 6 is a composite number. So remember, if then, that means left implies right. So it means 5 being less than root 26 implies that 6 is a composite number. Okay, and then we need to decide if the implication is true. So is 5 less than root 26? Well, root 25 is 5, so this is true. And is 6 a composite number? So every integer is either composite or it's prime. A composite number means it can be written as a product of primes. 6 is not prime, so it can be written as a product of primes, e.g. 2 times 3. So this is true, right? And if you have, for A implies B, if you think of the truth table, if you're trying to show that P implies Q is false, there's only one way it can ever be false. So if we say we have P and we have Q, right? And you're looking to see, does P imply Q? We have this little truth table. So you have 4 possibilities. You've got them both being true, P being true and Q being false, P being false and Q being true, and then both being false, right? So I'll try and separate this. Now, in logic, and it doesn't necessarily make sense or feel very natural, but for this implication, it kind of has to be proven false for it to be false. So if it's inconclusive, then you can't write false. So what I mean is, if P is true and then Q is true, then P implies Q could be true because P happened, and P was proven to be true, and Q was true. So you've got to say, well, we've got no reason to think that that can't be true. Right. If, however, P is true but Q is false, there's no way you can say that P implies Q because P happened but Q didn't. So this is false. If P is false and then Q is true, well, it doesn't mean that P doesn't imply Q because we don't know because, well, P wasn't true. So just because Q was true doesn't mean that P being true wouldn't imply it. So in that case, this is inconclusive, so this still gets a T in the truth table. If they're both false, the same reason. We never said that not P implied Q, we just said P implied Q. So if this is false and this is also false, then that's nothing to show that this isn't true, so we write that it is true. And that's just the rules. I can't do all about that. So that's the truth table for left implying right. So in our case, we have the left is true and the right is true. So if you look at that, when left is true and the right is true, this must be true. Okay, so that was the statement. What about the converse? So the converse, you need to switch them around. So it would be 6 is a composite number. implies that 5 is less than root 26. Okay, so again, we know that they're both true from part A, so if they're both true, then it must mean that the whole thing is true, because it's the first row in the truth table. For part C, we have, we now want the contrapositive, which is not Q implies not P, so it would be the negation of 6 is a composite number. The negation of that is 6 is a prime number. 6 is a prime number. Yeah, if you were to write a negation as 6 is not a composite number, it just shows a little bit of a lack of understanding about number, really. So that needs to imply that the negation of this. So the negation of 5 being less than 26 would mean that 5 would have to be greater than or equal to root 26. 5 would have to be greater than or equal to the square root of 26. So now we need to decide, is this true? Well, is 6 a prime number? No, it is false. Is 5 greater than or equal to root 26? No, it is not. It's smaller than, so that's also false. But if I take you back to the truth table, we're looking to see if left implies right. And when they're both false, well, that's not enough to say that this thing is false. In fact, you can only prove that left implies right is false when the left is true and the right is false. So the actual implication is still true according to the rules of logic.